An object is placed on the surface of this planet of the radius capital R, and from this point it is projected vertically with how much initial velocity? That is, according to the question, v escape over 5, 1/5 of the escape velocity of this planet. So what will happen initially? How much energy does it have? It not only possesses the potential energy, which is negative gmm divided by capital R, due to the gravitation, due to traction, but also the kinetic energy, maximum kinetic energy. So what will happen? Its kinetic energy will convert into the potential energy, and at some point when this mass will stop, at this point when its kinetic energy, final kinetic energy, will become zero, and it will have a potential energy that will be negative gmm over, we don't know about the height. That's what we have to find out, the distance from the center to this point. So I can say r plus h. So you have seen the kinetic energy has converted into the potential energy. So in this question you have to find out how far from the center. So how far from the center means you have to find h plus r, not only the height but also you have to add the distance r in it. Okay, so let's start. So you can apply the law of conservation of energy, because energy is converting from one form to another between the 2 points. So the total energy at the surface is the kinetic energy 1 over 2 mass of object and its speed, which is v escape divided by 5 whole square. This is the kinetic energy, total energy initially in the beginning, plus the potential energy negative gmm over capital R. So collectively this is a total energy just before throwing. So we can say at surface. Okay, so this total energy is equals to the total energy at the final point where the kinetic energy is 0 because this object has stopped, plus negative gmm over height plus r. That's the distance from the center of the planet. Okay, we can solve further, and interestingly, like if we cancel this small m on both sides, then it will be easy for us to further simplification. So it will become 1 over 2 into v escape square over 25 minus g capital M divided by r is equals to negative gm over r plus h. Okay, so you can take this thing to the other side. Okay, so 1 over 2 into, or you can also say v escape square over 50 is equals to negative gm over plus gm over r. Okay, now you can guess easily what we need to take a common from here. That's the gm, or if we take a negative gm, then what it will become? So negative gm, inside we have 1 over r plus h minus 1 over r. Now it's time to apply the value of v escape for any planet. The escape speed is the minimum speed required, so that with which if the object is thrown, it will go to infinity. Infinity, where the field strength is 0, where it will be outside the field of that planet. So we know that the v escape is equals to gm 2gm over r. So small r means orbital radius, which you can also say r plus h. Okay, so if we apply the value, but from the surface it is capital R. So I'm going to put the value of escape velocity here, and when we will take square, it will become 2gm over r, square root will cancel out, divided by 50 is equals to, here on this side we have negative gm, inside we have r plus h, which we can further solve, r plus h into r. So here we will have r, I'm taking LCM, minus into r plus h. I hope you understand. So what will happen? You can cancel out this 2 and this, it will become 25. So then it will be gm over 25 is equals to minus gm, inside we have r minus h into r plus h. I'm sorry it's getting long because it's a hard question, mathematically long. So gm and gm can be cancelled out, and what we are getting now, so that is 1 over 25 is equals to negative into this r, and this r is cancelled out, negative h over r into r plus h. So further this negative and negative will become positive, and you can say, what I forget, that we also have r here because we put the value of escape velocity, and its r is still here, which you can cancel out with 1r here. So this r and this r is cancelled out, so you can cross multiply, and what we will get, r plus h is equals to 25h. So from here r is equals to 25h minus h. So what is that? R is equals to 24h. So finally, what is the height equals to? R over 24. So this object will only manage to move at how much height? R over 24. But remember, do you remember I told you that what we need to do? We have to add r in it. So r over 24 plus r, that will be equals to 25 over 24r, because we need to find out the distance from the center of planet, not from the surface. So the right answer is option D.